Continued pre-training is how almost every specialized AI model actually gets built. Cursor used it to build Composer 2, Meta used it for Code Llama, and none of them trained the model from scratch. That cost hundreds of millions of dollars. Instead, they all took an existing general model and trained it further on domain-specific data. To understand how that works, you need to know where continued pre-training sits in the full training pipeline, because there are 3 stages and people constantly confuse them. Stage 1 is pre-training from scratch. You start with random weights. You feed it trillions of tokens from everywhere: books, websites, code, scientific papers, conversations, and over time it develops a general understanding of language, reasoning patterns, code structure, everything. And what you get at the end is a base model, a general purpose text predictor that knows a lot about everything but hasn't been optimized for any specific domain. Now, stage 2 is continued pre-training. You take that base model and then you train it further, but now on a narrower domain-specific data set. The training objective is still the same: predict the next token, but the data is different. For Cursor, that means feeding the model massive volumes of source code, engineering documentation, commit histories, programming data. And for a medical model like Meditron, it means clinical textbooks, PubMed articles, practice guidelines. For a financial model, SEC filings, financial documents. The general language ability from stage 1 stays intact, but the model develops much stronger representations of domain-specific terminology, patterns, and reasoning. Now, stage 3 is fine-tuning. People constantly mix up continued pre-training and fine-tuning because both involve training an existing model on new data, but they solve fundamentally different problems. Continued pre-training teaches a model what to know. You use large amounts of raw, unlabeled text, billions of tokens. The model reads domain text and develops deeper knowledge. Fine-tuning, on the other hand, teaches a model how to behave. You use a smaller data set of structured input-output pairs, questions and answers. The model learns to follow instructions, format answers correctly, act like an assistant. If you fine-tune a general model on medical question-answer pairs, it will learn to format answers like a doctor would, but it might lack the deep medical knowledge to actually get the content right. If you first do continued pre-training on medical literature and then fine-tune on medical QA pairs, now the model has both the knowledge and the behavior patterns. Meta did this with Code Llama. They took Llama 2 and ran continued pre-training on 500 billion tokens of code and code-related data. And for the 70 billion parameter version, they used the full trillion tokens. The data set included source code plus natural language about code, Stack Overflow posts, GitHub issues, documentation. The result was a model that understood code far better than General Llama, while still retaining general language ability. Cursor did the same thing to build Composer 2. They took Kimi K2.5, a general model with a trillion parameters, ran continued pre-training on software engineering data, and then applied reinforcement learning on top. Now, the big technical challenge with continued pre-training is catastrophic forgetting. When the model learns new domain knowledge, it can lose previously learned general knowledge. Trained too aggressively on medical tests, and the model might get worse at coding or general reasoning. So, teams manage this by keeping the learning rate low to avoid destabilizing existing knowledge and mixing in a percentage of the original pre-training data during training so the model does not drift too far from its general abilities. So that's continued pre-training. Every specialized AI model you use was probably built this way. Code Llama, Composer 2, Meditron, financial models, legal models, they all started from a general base and went through this step before anything else. If this was helpful, hit the like button, subscribe for more. Check out my new book as well, Get Insanely Good at AI, if you want to get insanely good at AI. But I want to hear from you in the comments.